I hope you don't have to excuse my voice. I've got a bad cold. I hope everybody had a good Thanksgiving.
Yes, we did.
Good. All right. What I want to do today, a couple things I want to go over first. I want to do some housekeeping, and then move into our lecture for today. Now, you had a couple of assignments to do over the weekend. You had that quiz I've given you, and I gave you a ration balancing assignment. I do have everything graded, so if you turned in a ration balancing assignment, I gave you a grade. If you did not turn one in, you got a 0. You can. I will accept.
I thought it was due tomorrow.
Well, that's fine. If it's due tomorrow, when I get it in, I'll change the grade. Not a problem. So go ahead and send it to me.
The quiz was, but the ration balancing.
Yeah, I did.
What other assignments
Well, I'd
were you
given you that
talking about?
quiz to fill out, and then you had the ration balancing over last week to do. I couldn't remember what day I told you to turn it in. Don't get excited. If I told you to turn it in tomorrow or have it in to me by tomorrow, just email it to me and I will change your grade.
I have a PA 12 house 15.
So don't get excited. I will continue to accept them.
Are you talking about the first quiz that we got to like it was a book? Yeah, like 13 and 14.
Yeah. They're all graded.
Okay.
Your grades are on Blackboard. And that went offline, I think, even before we went out for Thanksgiving break. I remember I opened it up for a couple people. But anyway, that's not a problem. But I got that all graded. And those of you that turned in your ration balancing assignments, I've got those graded. If they're due tomorrow, guys, go ahead and send them in to me, and I'll grade them and change your grade. Not a big deal. I did make another quiz available to you this morning, and you have until Sunday to get that complete. And it will be over the genetics and reproduction. And you can use your books, just like the last quiz. So there's no reason for you to make a bad grade on it. So make sure you do that quiz, and make sure if you haven't turned in your ration balancing assignment, turn it in. Now, guys, I've been seeing some common problems in that ration balancing assignment. The number one problem I've seen is when you set up the Pearson square, and you're coming up with the percentage of each ingredient of the corn and the hay, you're reading that diagonal. You need to read it straight across. So your hay is always going to be the greatest portion of your ration. Corn or any type of grain you feed will be the smaller part. And a lot of people are getting that confused, getting that switched around. So hay is the basis of your ration, and that's going to be the largest portion of your ration. That's the main issue I'm seeing. One of the main issues. The other issue I'm seeing is once you get the percentages of corn and hay that you're feeding, you're not taking it down to the pounds of dry matter of each ingredient. you're saying you're feeding the cow 88% corn, 88% of ration corn, and 11% of the ration, or 88% of the ration hay, 11% of corn, whatever the numbers are. Remember, guys, you got to take that 88% and multiply that by your dry matter intake. You'll get pounds of hay. That makes sense? So instead of giving you the percentage, you give pounds. And those are the two major mistakes that I've been seeing. The third major mistake was on the pricing. Some of that was carried over because of the ration was wrong, but I did that. But what you need to do is figure out, like I gave you, corn is $7 a bushel, so you need to take the 7 and divide that by 56 pounds, and that'll give you how many dollars a pound. Corn. So it's going to be like 76. And you're going to multiply that by how many pounds of corn you're feeding the cow. And the same thing. The price of that hay, $60 a roll divided by 1,200 hay. You get how many cents per pound of hay. So those are the three big mistakes that I've been seeing. So keep an eye out on those for those of you that haven't done them. And if you did do them and you didn't get 100% and you wanted to redo it, you're welcome to redo it. Send it back. Those are the three big mistakes. And I can tell who worked together because the whole group was 2 or 3 people at the time. And I told you you can work together, that's fine. So, but call me, guys, if you have any questions. I have been getting phone calls over this, and I'm more than willing to help you out. Okay, I'll call you back and help you out, make sure you get it. So don't be afraid to call me. So go ahead and get that sent in to me, and I will adjust your grade accordingly. Now, so you got the one quiz that I made available today, genetics and reproduction, and your ration balances. Today I want to go over reproduction. We're starting that chapter. Now, guys, the two things I'm real big on: nutrition and reproduction. All right, so your crutches. That's your whole management, the whole farm is going to run around those two deals. You got to feed your cattle properly, and you got to feed them properly in order for them to be reproductive, to be reproductively efficient. So you got to have a calf every year. And if you don't have a calf every year, your cows don't get pregnant, you don't have any cows to sell, so you're going to go broke. So these two chapters and balancing rations, I do put a whole lot of emphasis. So I do recommend you to read the reproduction chapter as well. And before, I've got a video here I'm going to show you guys that explains it a whole lot better than I can. But before I start that video, I want to do something first. So, if you guys will take out paper and a pen, what we're going to do is we're going to make a chart, and you're going to learn, and I want you to pay attention in this video and complete the chart as this video goes on. Otherwise, I think some of you guys complete it. If you don't complete it, then videos, and you will, you know, you will most likely be completed because I will have exam questions for you. And you will have a lot of exam questions regarding the hormones. So, let's just list out these hormones and what I expect you to know. I'll let you do the research on it, but I will get you started. And because of my cold and because of the mic issues, it's going to be hard for me to talk.
Is he talking?
No, I'm not.
I was about to wonder what was going on, Dwayne. I was just, he's in the
I've
drawing
made about
stage.
3 of them, and I keep leaving something out.
Okay.
Okay, so what I have here, and we may have to add a couple more stuff on here. I have the hormone. I have hormone, the origin of that hormone. What is its target, or what's its intended purpose of that hormone? And what other interactions with other hormones? Okay, because they do work in conjunction with each other. Okay, so you need to know the hormone, what gland or organ produces the hormone, what does it do, what's its mode of action, and are there, what other hormones work with it. Okay?
Interaction with other
So, let me list out some of these hormones. Play a video. you guys see those?
The bottom two are, the bottom four are a little, number 3 is a little hard for him to read, and
They're on page 317 in your book. 317 in your book.
that helped.
Does the first one have 2 H's or 1?
Come on, 2. That's it.
Okay.
It's a GN.
RH. Again, a trophy release in London.
Alright, so how many of y'all synchronize your cows? And do artificial insemination?
We can't see it.
Alright, what can't you see? You can't see the document, can you?
Yes, sir.
Alright, is that what, I don't know what to do. What, I mean, you can't, what are you seeing on the screen?
We can see it. Like, it's every time Patrick Henry, it's like it keeps going back.
Like
to
when you
Patrick
stop
Henry.
talking or something, it goes back to Patrick Henry.
Okay, so y'all talk, keep it up on, right.
Dwayne's the one that's got it.
Then we can't see it.
Dwayne's the one that's got to talk to keep it going.
Well, they've got to talk at Keysville to pop that screen to him. I don't know how. However you got to talk so you can see it. You guys see it now?
No.
We can just see each other.
You haven't talked enough, Dwayne, to trigger it back to your location.
Okay. All right. I don't know what had a feeling fell out.
Prostaglandins. What was after that?
And it broke off.
Anybody? I know estrogen, testosterone.
Estrogen was the bottom one.
Okay, and then so it was testosterone,
Mhm.
testosterone.
So the hormones, GnRH, FSH, LH, prostaglandin, PGF2 alpha, estrogen, progesterone, testosterone. So what you're going to look for in this video is you're going to find out.
I really can't hear you.
Yeah, me either.
Alright, so you have GnRH, FSH, LH, prostaglandin, estrogen, and progesterone. So in this video, you're going to figure out where these hormones are produced, what are their modes of action, or their target area, and what are they supposed to do. And are there interactions with other hormones? So, like, take GnRH, for example. Verse 1, it is produced in the hypothalamus. The target is the pituitary gland, and it causes the release of FSH and LH. So that's its mode of action. Interactions with other hormones. it's progesterone will kind of help control that release of GnRH. So it does interact with progesterone. And estrogen causes to release more. So it interacts with progesterone. And that's the main thing. So if you're ready, everybody got that? If you're ready, we'll start the video.
Can you say the target one more time?
The target of GnRH is going to be the pituitary gland. It's going to cause the release of FSH and LH.
Okay, so the origin is also the pituitary gland?
No, the origin is the hypothalamus in the brain.
Okay.
For the GnRH. It stands for gonadotropin releasing hormone. So, hopefully this will help you pay attention to the video. Are y'all ready for the video now? You guys at Keysville ready?
Yes, sir.
South Boston?
Yes, sir.
South Side?
Yes.
And Patrick Henry?
Yeah.
All right.
Successful artificial insemination programs are based on a clear understanding of the anatomy and physiology of reproduction in cattle. Before attempting to inseminate cows, you must develop a mental picture of the anatomical parts that make up the female reproductive tract. In order to understand why an animal displays the many signs of estrus, when she should be inseminated, and how the pregnancy develops, you must also clearly understand the hormonal mechanisms controlling the estrus cycle in cattle.
Okay, one other thing that you'll need to pick up, either in this video or the next one I show, are the signs of heat. That will also be an important question. In cattle, what are the signs of heat?
First, let's look at the parts that make up the reproductive system in cattle. There are 2 ovaries, 2 oviducts, 2 uterine horns, a uterine body, the cervix, the vagina, and the vulva. The bladder lies below the reproductive tract and is connected at the urethral opening located on the vaginal floor. The rectum is located above the reproductive system. The vulva is the external opening to the reproductive system. The vulva has 3 main functions: the passage of urine, the opening for mating, and serves as part of the birth canal. Included in this structure are the lips and the clitoris. The clitoris is analogous to the penis in a male animal. The vulva lips are located at the sides of the opening and appear wrinkled and dry when the cow is not in heat. As the animal approaches estrus, the vulva will usually begin to swell and develop a moist red appearance. The vestibule includes the vulva and the interior portion of the reproductive tract extending forward to the urethral opening. The vagina, about 6 inches in length, extends from the vestibule and urethral opening to the cervix. During natural mating, semen is deposited in the anterior portion of the vagina. The vagina will also serve as part of the birth canal at the time of calving. The cervix is a thick-walled organ forming a connection between the vagina and uterus. It is composed of dense connective tissue and muscle and will be our primary landmark when inseminating cattle. The opening into the cervix protrudes back into the vagina. This forms a 360-degree blind-ended pocket completely around the cervical opening. This pocket is referred to as the fornix. The interior of the cervix contains 3 or 4 annular rings or folds. This design by Mother Nature facilitates the main function of the cervix, which is to protect the uterus from the external environment. Learning to manipulate the cervix and the cervical rings over the insemination gun is the primary obstacle for the beginning inseminator. The cervix also functions as a barrier to sperm transport after natural mating. This results in a filtering of abnormal sperm cells from the ejaculate, allowing only the fittest to continue toward the site of fertilization in the oviducts. Because we can bypass the cervix and its barriers to sperm transport, only a fraction of the number of sperm cells are required for normal fertilization rates with AI, as opposed to natural mating. The uterus and lower portion of the oviduct also filter abnormal sperm cells in both natural and artificially serviced animals, again resulting in only the fittest sperm competing for fertilization of the egg. The cervix also completes the final segment of the birth canal. At the time of calving, the cervix dilates in response to the hormone relaxin, allowing uterine contractions to expel the calf. The cervix opens anteriorly into the uterine body. About an inch long, the body of the uterus serves as a connection between the 2 uterine horns and the cervix. The uterine body is the site where semen should be deposited during artificial insemination. From the uterine body on, the reproductive tract separates and all further structures come in pairs. The 2 uterine horns consist of layers of muscle and a heavy network of blood vessels. The main function of the uterus is to provide a suitable environment for fetal development. When a cow is bred, either naturally or by artificial insemination, the uterine muscles, under the influence of the hormone oxytocin, rhythmically contract to aid in sperm transport to the oviducts. Oviducts, as their name implies, carry ova, the cow's eggs. The oviducts are also commonly referred to as the fallopian tubes. The oviduct has several distinctly different regions when examined microscopically. The lower segment, closest to the uterus, is called the isthmus. The connection between the uterus and the isthmus is called the uteral tubal junction, or UTJ. The UTJ functions as a filter of abnormal sperm, and the isthmus as a reservoir for healthy sperm. Research suggests that upon gaining access to the isthmus, healthy spermatozoa attach themselves to the walls and wait for a chemical signal that ovulation has occurred before continuing on to the site of fertilization. During this period of attachment, many physiological changes occur to sperm membranes, which are essential to attainment of fertilization potential. These changes are collectively referred to as capacitation and are apparently regulated by this very important attachment to the walls of the isthmus. It takes about 5 to 6 hours after insemination before a sufficient number of fertile sperm cells can populate the isthmus and complete the capacitation process. The upper portion of the oviduct closest to the ovary is referred to as the ampulla. The interior of the ampulla is more open than the isthmus, allowing for easier passage of ova. It is within this segment of the oviduct that fertilization actually occurs. It is believed that a chemical signal released at the time of ovulation stimulates the release of spermatozoa from the walls of the isthmus, allowing them to continue their journey to the site of fertilization in the ampulla. Ova are recovered by the large open end of the oviduct, which surrounds the ovary. This funnel-like structure, called the infundibulum, keeps the ova from falling into the body cavity. Hair-like structures on the infundibulum and within the ampulla carry ova and a surrounding mass of cells called the cumulus mass down the oviduct to the site of fertilization. For reasons unknown, the cumulus mass is apparently very important to ovum transport. Glass beads, or ova without a cumulus mass, simply rotate in place on the ciliated cells and are not actually transported. The ovaries are the primary organs in a cow's reproductive tract. They have two functions, to produce eggs and to produce hormones.
Yeah, you need to know that. Primary organ, cow's reproductive tract.
Do what?
Got that down. Ovary. Produce eggs and produce
Can't hear you, Dwayne.
Yep.
Oh, you'll need to know what's the primary organ of a female reproductive tract, and that's going to be the ovary. And its function is to produce hormones and to produce eggs.
Namely estrogen and progesterone, throughout the different stages of the estrous cycle.
Let me back
On
that
the
up.
cumulus mass is apparently very important to ovum transport. Glass beads, or ova without a cumulus mass, simply rotate in place on the ciliated cells and are not actually transported. The ovaries are the primary organs in a cow's reproductive tract. They have two functions, to produce eggs and to produce hormones, namely estrogen and progesterone, throughout the different stages of the estrous cycle. On the surface of the ovary, you will usually find two distinctly different types of structures. Follicles are fluid-filled, blister-like structures that contain developing oocytes, or eggs. Usually, you'll find numerous follicles on each ovary that vary in size from barely visible to ones 18 to 20 millimeters in diameter. The largest follicle present on one of the ovaries is termed the dominant follicle and is the most likely candidate for ovulation when the animal comes into heat. Over time, greater than 95% of the other follicles on the ovary regress and die without ovulating and are replaced by new crops of growing follicles. The other structure found on the ovarian surface is the corpus luteum, or CL. The CL is the site where ovulation occurred during the previous cycle. Unless there were twin ovulations, you should find only one CL located on one of the two ovaries. The CL will usually have a distinct crown protruding from the ovarian surface, which facilitates identification during rectal palpation. The CL may also have a fluid-filled cavity, but usually has a much thicker wall than a follicle, and thus a much denser texture when felt by palpation. Corpus luteum is Latin for yellow body. While the outside of this structure is usually dark red in appearance, a cross-section reveals a bright yellow to yellow-orange interior. Those are the parts of a cow's reproductive tract. Now, let's see how the hormonal system works. Over a period of time, many changes take place in the reproductive system in response to changing hormone levels. These changes in non-pregnant normal females repeat every 21 days. This regular repetition is called the estrous cycle. Let's discuss how the estrous cycle works, starting with a cow in heat on day 0. Looking at the reproductive tract, we see several things happening. One ovary has a large follicle, approximately 15 to 20 millimeters in diameter. This follicle has a mature egg inside, ready to be released. The cells lining the follicle are producing the hormone estrogen. Estrogen is transported in the bloodstream to all parts of the cow's body, causing other organs to react in a number of ways. It makes the uterus more sensitive to stimulation and aids in the transport of semen at the time of insemination. It causes the cervix to secrete a viscous mucus that flows and lubricates the vagina. Estrogen is also responsible for all signs of heat, including a red, swollen vulva, allowing other cows to mount her, going off feed, bellowing considerably, and holding her ears erect are but a few of the many signs. On day 1, the follicle ruptures or ovulates, releasing the egg to the waiting infundibula. Several hours prior to ovulation, estrogen production declines. As a result, the cow no longer displays the familiar signs of heat. After ovulation, new types of cells called luteal cells grow in the void on the ovary where the follicle was located. Quite rapidly over the next 5 to 6 days, these cells grow to form the corpus luteum. The CL produces another hormone, progesterone. Progesterone from the CL prepares the uterus for pregnancy. Under the influence of progesterone, the uterus produces a nourishing substance for the embryo called uterine milk. At the same time, progesterone causes a thick plug to form in the cervix, preventing access of bacteria or viruses into the uterus. Progesterone also prevents the animal from returning to estrus by blocking the release of follicle-stimulating hormone from the pituitary gland in the brain. Follicle-stimulating hormone, or FSH, as its name implies, stimulates the growth of follicles. Rapid follicle growth usually results in estrogen production, which would bring the animal back into heat. This would make life difficult for a new embryo if she were pregnant. Thus, progesterone's block to FSH is a very important aspect of maintaining the pregnancy. On the other hand, if we did not breed the cow, we do want her to come into heat again. Days 16 through 18 of the estrus cycle are referred to as the period of maternal recognition. During this time, the uterus searches itself for the presence of a growing embryo. If no embryo is detected, the uterus begins to produce another hormone called prostaglandin. Prostaglandin begins to destroy the CL. When the CL is destroyed, no more progesterone is produced, and the pituitary gland begins to secrete FSH. This rise in follicle-stimulating hormone initiates the selection of a new follicle to grow to a large size, produce estrogen, and bring the animal back into estrus. A full cycle is now completed. The average total time is about 21 days. The estrus cycle is subdivided into 2 phases based on the dominant hormone or ovarian structure during each phase. The luteal phase begins when the corpus luteum is formed, about 5 to 6 days after the cow was in heat, and ends when the CL regresses, about day 17 to 19 of the cycle. Progesterone levels are high during this phase of the cycle, and estrogen levels are low. The other phase of the cycle, the follicular phase, begins when the CL of one cycle is regressed and ends when the new CL of the following cycle is formed. Thus, the follicular phase encompasses the period of time surrounding estrus. During this phase of the cycle, estrogen levels are typically high, while progesterone levels are low. As mentioned earlier, follicles may be present on the ovaries throughout the estrus cycle. Research using ultrasound technology has characterized follicular growth as occurring in waves. Normally, an animal will have 2 or 3 waves of follicular growth during a 21-day cycle. The beginning of each wave is characterized by the rapid growth of numerous follicles. From this wave, or crop of follicles, and by mechanisms still unclear, one follicle is allowed to grow to a much larger size than the others. This large follicle is referred to as the dominant follicle, as it has the ability to regulate or restrict the growth of all other follicles on the ovary. Dominant follicles only remain dominant for a short period of time, 3 to 6 days, which is followed by cell death and regression. Consequently, disappearance of the dominant follicle coincides with recruitment of the next crop or wave of follicular growth. From this new wave, another dominant follicle will be selected. Although it is typical for much follicular growth to occur throughout the estrus cycle, low levels of FSH during the luteal phase, when progesterone levels are high, prevents these follicles from producing high levels of estrogen, which would bring the animal back into heat. It is only the dominant follicle present at the time the CL regresses and when progesterone levels are low that is permitted to produce enough estrogen to bring the animal back into estrus and to continue on to ovulation. Let's follow the events that occur after insemination. For the first 4 to 5 days, it would move in the oviduct toward the uterus. Once the egg gets there, it will be bathed in uterine fluids and continue to grow. While floating free in the uterus, several membranes, including the amnion, the chorion, and the allantois, are produced by the new embryo. Collectively, these membranes are referred to as the placenta. Hopefully, by the time the period of maternal recognition arrives, days 16 through 18, the fetus and growing placenta will have produced adequate quantities of the chemical signal required to maintain pregnancy. This chemical signal interferes with the action of prostaglandin on the corpus luteum. The CL is thus retained and continues to produce progesterone, which is essential to maintenance of the pregnancy. At about 30 days of gestation, the placenta begins to attach to the uterus at several points. The placental side of these attachment points are called cotyledons, while the uterine side has caruncles. The attachment of cotyledons to caruncles is very similar to Velcro. This greatly increases the surface area within the attachment point. Surface area within attachment points is important to allow for exchange of nutrients and waste products between calf and mother by way of arteries and veins leading to and through the umbilical cord. At calving, the muscles in the uterus begin to contract and eventually expel the calf and membranes through a dilated cervix and vagina. Several hormones, including progesterone, estrogen, prolactin, relaxin, and corticoids, produced by the mother, the fetus, and the placenta, interact to bring about this event. Calving in a clean environment and proper treatment of the cow after a difficult calving will help prevent reproductive problems. Becoming familiar with the reproductive anatomy and physiology of a cow will help you do a better job artificially inseminating your cattle. Understanding how the hormones involved in the estrus cycle interact to control this phenomenon gives you clearer understanding why and when animals display the many signs of estrus, how pregnancy is maintained, and of what you or your veterinarian must do to treat cows who don't cycle normally.
Okay. Did you fill in most of those hormones? All right. Did you fill it in? What do you got?
For LH, I wrote the origin was the pituitary gland and it causes ovulation.
Okay. Uh, it also it also causes the formation of corpus luteum.
Of the of the corpus luteum.
It causes ovulation. That is correct.
Okay.
And it also causes those luteal cells to form. That's where it gets its name, corpus luteum. I mean, luteinizing hormone. So you got that one. And where does it originate from? LH.
Pituitary gland.
Pituitary. So you know its mode of action, what it does. Okay. What else do you have?
It's a glycoprotein hormone.
It interacts a lot with GnRH because that regulates it. And that's going to be dependent on the levels of progesterone, estrogen. Same thing with FSH. That's going to be its progesterone regulates it. It's that signal. If it's high, then the GnRH makes sense. All right, what did you say? Another question.
So it stimulates the CL to produce progesterone. That's the interaction.
Which one? Okay, what
LH.
LH, when estrogen levels are high, signals the brain or the hypothalamus to release a big gut or have a big release release in GnRH, and the GnRH causes the pituitary to release a whole lot of LH, and the LH causes ovulation. Once that's ovulated, then it starts to form. Once that follicle's ovulated, it starts to form the corpus luteum. So LH causes ovulation and the formation of those luteal cells for the corpus luteum. The corpus luteum, which is located on the ovary, where the follicle was, produces progesterone. And progesterone, we know that will maintain, it prepares the uterus for pregnancy. If the cow's pregnant, it will maintain the pregnancy. And progesterone, when it's high, it inhibits the release of FSH, the follicle stimulating hormone, so you don't have that cow coming in the heat all the time.
I'm sorry, when it's high at what? When progesterone is high at what?
It tells the brain, hey, I may be pregnant here. Don't release FSH.
Okay.
So GnRH, that production of GnRH, the release of GnRH from the hypothalamus, it's not being released until the pituitary releases FSH. So it prevents the release of FSH.
Okay.
So that progesterone level maintains high throughout the pregnancy.
Okay.
If the cow's not pregnant, then the uterus produces a hormone called prostaglandin. We call it PGF2 alpha for short. There's several different types of prostaglandin. But it produces prostaglandin, and prostaglandin acts there on that corpus luteum, there on the ovary. It will knock out that corpus luteum. It'll cause it to regress. So when it regresses, that the progesterone production stops. When it stops, then we start getting the release of FSH to encourage those follicles to grow. And that follicle that's growing produces estrogen. When estrogen reaches a certain level, that cow starts displaying signs of piggy. And the video went over those yesterday. And it will reach a threshold level. When it reaches that threshold level, LH is released and causes ovulation. Make sense? Do you have any other questions? So if I ask you, what are the two major hormones produced from that are, that ovary produces, what do you tell me? Estrogen, progesterone. That is correct. The ovary is responsible for both of them. The follicle produces estrogen and the corpus luteum produces progesterone. If I ask you what hormone the uterus produces, what are you going to tell me? Prostaglandin. Okay, and what does prostaglandin do?
It destroys CL in if there's no embryo and stimulates contractions.
Okay. It will destroy the CL and the cow. I'm not going to ask you anything about the hormones in the cow. Don't worry about the hormones.
Didn't hear that, Dwayne.
What's that?
Just didn't hear that last little statement you made. I don't know what it was.
I'm not going to ask you the hormones regarding calving or parturition, but I am going to ask you about the hormones regulating the estrous cycle. I have another video about estrous synchronization in beef cattle that I want to show you, but it's about 25 minutes, and we're not going to have enough time to get through this. And that video is going to go talk about the hormones as well, and it's going to talk about the specific hormones that we use for synchronization drugs, and those are going to be exam questions as well. So what hormones can you guys think of after going over these hormones and how they're used in the estrous cycle? What hormones do you think we could use to synchronize the estrous cycle in cattle?
Utilize.
Lutelyse. Lutelyse is a trade name, okay? The hormone that it mimics is prostaglandin. So, how does that work? How does Lutelyse work?
I think I know it stops them from cycling, and they all kind of quit at the same time. And then you give them, I can't exactly remember, but you give them something else, and then they all come in here at the same time.
Oh, that's close enough.
Okay. Lutelyse has been around for a long time. And as I said, it's the hormone prostaglandin. So, what does prostaglandin do? I just asked you that question. So, what you tell me what it does?
If there's no
It stops the production of progesterone.
Exactly. It luteolized or prostaglandin causes the regression of the corpus luteum. And when it regresses, the progesterone stops. So, luteolized, we give a cow a shot of luteolized. Theoretically, it will knock out that corpus luteum. And she should come into heat within about 3 days. Now, if we had a herd of cows out there and we rounded them all up and we gave them a shot of luteolized, is it going to work on all those cows, just one shot? No, it won't. And the reason why it won't work is because in order for luteolized to work, you have to have a corpus luteum. All right? That makes sense? So, if the cow doesn't have a corpus luteum, it's not going to work. So if the cow's already in heat, it's not going to work. If she's just had a calf and say like about a month ago and she hasn't started cycling yet or resumed her estrus cycles, it's not going to work. Yeah, the certain percentage you can. If you've got a bunch of heifers, yearling heifers that you're wanting to synchronize, if those heifers haven't started cycling yet to produce a corpus luteum, it's not going to work on those heifers. So they have to be cycling, and they have to have a corpus luteum. The other drawback with just that one shot of luteolized is within that first 10 days, I think, or 7 days, that corpus luteum, if the cow's just gone out of heat and she's forming that corpus luteum, it's protected really, really heavy. And so that shot of luteolized prostaglandin is not going to work on that cow because that corpus luteum is being protected from that shot. So that it needs to be about day 11 into that cycle for that to work. So there are some drawbacks with one shot of luteolized. Because if they're already in heat, or if they're just coming out of heat, or they're getting ready to go into heat, and the corpus luteum is regressing anyway, or they haven't started cycling, those are the cases it's not going to work. So what they used to do, or what we did, we would give them a shot of luteolized, watch them a few days, and breed anything that came into heat, and then we would come back on day 11 and give the remainder of the cows another shot of luteolized. And so we picked up those, say, between day 18 and day 7, and we were able to get those synchronized. The luteolized is a great drug. We still use it today in synchronization methods. You can use it as a standalone drug, or you can use it in combination with other drugs. And it's done with both. Some producers just use it as a standalone drug, but most of them now, with today's advancements, we use it in a combination of other drugs or other hormones. So we use a combination of hormones to synchronize. So that was a really good answer. I know I gave you a long version of it, but that's how it works. What other drug or what other hormone do you use in synchronization? Any ideas? Okay, you guys at Southside, one of you mentioned that you use Ludolice in combination of some other stuff. Do you know what your other stuff is you're using?
No, sir.
Is relaxing one of them?
No, we don't. Relaxing is usually used for calving if we're wanting to induce parturition. You can give them some oxytocin, relaxin, and some glucocorticoid steroids, and get that initiate that calving for the parturition. But that's not a typical hormone that we think about. Do you use when y'all synchronize cows? Do y'all put that vaginal implant in them? Cedars.
Yeah, we use cedars.
Okay. Do you know what drug that is?
Is it permectin?
It's progesterone. That's
Okay,
the hormone.
well.
That's the hormone that it regulates, or that's the hormone it mimics. Is progesterone.
Okay.
So you use the cedars, prostaglandin, and then you also give them a shot of something else. Do you know what that one is?
No.
Is it cisterellin? Or what's the other name? The other cisterellin and I can't think of the other brand. But it's that drug mimics GnRH. So the three hormones that we use are drugs that mimic the hormones are GnRH, progesterone, and prostaglandin. So this next video that we'll show, and I'll show this to you first, will explain how GnRH works for synchronizing estrogen, and how progesterone works, and prostaglandin, and how we can use it all three to get a really tight synchronization. Because now we can use all three drugs and go in there and inseminate the herd all at one time and get pretty good conception rates. So you may have to run them through the chute 2 or 3 times, but we can just inseminate them all at the same day. And we don't have to heat check as much, or you don't have to do it at all if you don't want to. So I'll let you guys out a little bit early today. My voice is shot. Go to your book, read that chapter.
We don't have class Thursday, right?
You'll have this class. Yes.
Okay, you will,
Yes.
okay,
Yeah, you'll have,
Okay.
I won't be here, but
okay.
Megan knows how to turn the machine on. She's gonna do that. But I won't be. I'll be in Winston with my wife.
Okay.
Okay? Sorry, it's just, I can't help it.
Okay.
Yeah, but, you know, Dwayne will be there and he'll do just like he normally does for here.
Okay.
We'll give Megan the task of dealing with the electronic equipment, and if there's a failure to communicate, we'll blame it on her.
So we don't have a lab that Friday or,
Be no more lab, no lab.
all right.
So we'll finish filling out that chart, and I think that the next video will help you do that, and I'll give you another chart to fill out. Take the next page. If you have any questions, give me a call, especially okay? I will help you out any way I can.
John, when can I do my sign up for my classes? Can I come tomorrow to sign up for my classes?
I won't be here at all tomorrow. I've got pre-op tomorrow. We need to do it this afternoon.
I gotta go to Louisville right now.
They won't let you, no, I'm playing.
Because I mean, I don't know when I'm in.
We can do it anytime next week,
Okay.
okay? I just, I can't do it tomorrow. I'm not even coming to campus. I gotta be in Winston,
Wife's grandmother died.
leave by
Do you just want me to wait and do them with her?
Nah.
Okay. Just wait till next week.
Yeah, that's fine. Whatever you want to do.
Or actually, I mean, you said you were gonna put me in port class, but that was before. I don't want like a real strict semester
Well,
because of what's going on.
calculus and biochemistry.
That's what she needs.
I like chemistry.
The two more classes will work, but I've gotta look at that
Okay.
and see, but, you know, but
Well, I mean, if I actually could do hers today and then like just to get an idea, so I could look at it or something, you know what I'm saying? If she could get her classes, and then while you're looking, you know what I mean?
we'll do whatever you guys wanna do. I'll
That
be
way,
back.
because I know Ashley needs to get in that one so she can have it this.
What is that?
The book says it's finance, something's only offered in the spring.
We offer it every semester.
Oh, okay. It was more classes, it was like, the book says like, oh, it only offers it. Okay. Okay.
Because, I mean, whatever I could be in, I could just go ahead and let my doctor know today, like a possibility of my schedule, or, you know, so I could schedule one.
We'll work with it, okay? To be honest, yesterday, I had a situation come up. The two board classes, which is gonna be in conjunction with the door enrollment, the ladies gonna be there every day. And, so Jeff was talking about possibly switching it from a Tuesday, Thursday to a Monday, Wednesday. So we'll do that.
Okay.
Those kids didn't take it, so we were set up for Tuesday, Thursday. We'll do that. Okay?
Alright, so I'll plan on seeing you Monday then.
Yeah, that's, as far as I know, that'll work. Okay, and actually, we'll do whatever.
So I respect my wife's saying make a tough call, but I think it is, and you know, I mean, it's not, you know, not like they used to be, but you know, they didn't. You know, she just didn't try to get smart. I know that. She kept